Hey Algebra, let's look at 15-6. I'm going to film the notes for you, so you'll have to stop this video and get those copies in. We talked about how you could apply quadratics in class. We looked at, usually you don't have all the money in the world. You actually have X amount of supplies, and that's what you have. So when they have so many supplies, that's the best they can do. So if you're looking at that graph, you've got some options. You can make this thing 5 feet long, and the area is going to be around, what, 250? But you could also make it 25 feet long, and the area would be just over 600 feet. So first of all, it depends on what you want to put in that pen. Is it a dog pen, or is it for cows? And I can tell you from a cow perspective, that's a terrible cow pen. So, but do you want lots of area? Do you want long and skinny? And what is the best shape that has the least amount of perimeter, but the most area? Yep, a square. If you were ever going to build a swimming pool and you had to pay for lateral, you would build a square because the perimeter is less than the area. Of course, most people don't have a square swimming pool, but it is true nonetheless. If you're paying for perimeter, you want a square. If you're paying for area, well, that's just what you get. All right, so let's look what you got. So it says identify the independent variables. Wouldn't that be Dr. ID, XY, list 1, list 2? Dr. ID, XY, list 1, list 2. Yep, input, output. Y'all be sure to teach Coach Wynn. So what do we have here? We said independent. Wouldn't that be independent? So that's your X. And then it says dependent. I think that's my Y, and that's area. And then it says they want the X-intercepts. Well, they cross 0, 0 here, right? And they cross at 50, 0 here. Careful, make sure the 50's first. Does the graph has a max or a min? Well, it's a mountain, so that's going to be your maximum point before you come off that mountain, so that's a max. What is the vertex of the graph? What does vertex mean? That is where it breaks. So think about of waves in the ocean. That's going to be where that wave breaks, and then you see that wave crashing down. And that would be at the top of your graph, and that's going to be right there. And if you look at their ordered pair, they said 25, and I'm going to put a dot right there actually so you can see it better. So you got 25, and they said 625. Probably the better question is, what are they going by over here? What is this y-axis traveling at? I can see that the x is running at 5, so you got 5, 10, 15, 20, but what about these over here? So you've got 1, 2, if I can see correctly, 1, 2, 3, 4, and then you have 100 at 4. So my guess is at 25. So 100 divided by 4 is 25. So, and if you're not sure how to figure that out, you take that number, divide by how many squares from 0. That'll tell you the spacing. It's 25. And if you go back to the mountain, we're one tick mark past 600, so 625. And that explains that answer. Next, how does the x value of the vertex relate to this scenario? It is the length of the maximum area. So they want to go the x value of vertex. So first of all, that's the vertex. That's the x. So what is the 25? Well, 25 is length. That's the length of the maximum area. And including that maximum area is going to help you some, because you got to realize that's as long as you can make it. If you made it longer than 25 feet, you don't have enough supplies, and you'll be traveling to town to go buy more supplies. Next, question 6. How does the y value of the vertex relate to this scenario? The y value is area. And that's your max area. So if you wanted to build whatever, some pen, and you wanted 700 square feet, well, you don't have the supplies to begin with, because the max is 625. So, and if you want anything less than 625, you certainly have the supplies, and you'll have the word called leftovers. Perfect. Question 7. Draw the possible dimensions of the corral if the area is 525 square meters. Draw and label all possible answers. So, and it said 525 square meters. So you're going to go back over here and find 525. So there's 500. That's 525. You've got option A, and you've got option B. That's where they're getting to. You're drawing both, because remember, those are both, what are those words? That could be like x-intercepts. Those are solutions also, because you're looking for a specific. So then it looks like to me that's going to be 15. And 15 times blank is 525. So 15 times blank is 525. And this polka dot is 35 feet. So then that's going to be 35 times what is 525. And when you just divide those by 15, and you get 35, and you get 15. And off we go. And how about we put that on the screen? So 15 times what's 525, and 35 times what's 525. Yep, you got the numbers. All right, the back page. All right, so they're looking at launching a rocket. Each person in the group chooses one rocket to analyze. Answer the following questions with the rocket. We don't have rockets, but we do have fireworks. Now, if you bought some fireworks, and we've all experienced the fireworks, and you light them, and now the other question is, why aren't you starting at 0? Because I'm not the height of an ant. So I'm probably not 10 feet tall. We'll pretend I am. Maybe Taylor let it. Maybe I put it on a container. By the way, this is a rocket, so that might be where the top of that rocket is. Who cares? But back to the fireworks. I'm actually not 0 feet tall. I know I'm short, but I'm not that short. So here's me standing. I'm going to light that thing or put it on a container, and it's going to go off. It's going to have its max, and then it's going to come right back down. And note to self, I wouldn't stand here. So think about this. You know, I can remember years ago when I took the boys when they were little to go watch fireworks in Cameron. Cameron would have free fireworks. Rockstone Cameron traded off. And I can remember getting there early, wanting to be first in line, be in the front. The boys can see. They're all excited. And we were camped out right there in the front row. Little did I know, when they lit the fireworks, they rained down on us. So the boys didn't get to watch as many fireworks as they got to dodge a lot of fireworks. So, yeah, note to self. If you're ever watching fireworks, maybe you want to know where they're going to land, because where we were sitting, they were landing. So it was up close and personal, too close. So let's get ready with this question. Number 1, A, it says independent and dependent. Wouldn't that be X and Y? So that's time and that's height. Next, the height depends on the time. Next, from what height was Bob's rocket launched? Well, if you're looking at it, he must be 10 feet tall. He's not 10 feet tall. He must have set it on something that's 10 feet tall and apparently used a ladder. And by the way, that says meters, 10 meters. Was that more than 10 feet? Yeah, that's 10 of my meter sticks. Okay, that boy's in a tall tree. Next. You know, and if you're looking at the seconds, you know, when did it hit the ground? I'm looking over here. You see time. And here's 3.5. Here's 4. That's 375. So it's between 375 and 4 seconds. So what, 380? You can estimate. You could put a zone. So between 375 and 4 seconds. And I'm okay with the zone because that's getting to the real tight on estimation here. Next, when did the rocket reach its greatest height? Well, that would be the top of the mountain. That's looking like just above 65, but it's less than 70, so I'm okay with 66 or 67. I'm not okay with 70 though. Let's see here. What's the next one? How many seconds was the rocket in the air? Well, looks like to me it started here and it stopped at 4, so about 4 seconds. Almost, but close. And the word about helps with that word estimation. Next, and get a screenshot of those answers if you haven't caught up yet. Next, for the next one, for approximately how many seconds was the rocket 45 meters or higher? So find 45, and then looking at your graph. So it's at 45 was right there. And it went all the way over here, and about here's where it stopped. So this is at what, 0.75? And then it stopped at 3. So then 3 seconds minus 0.75 is 2.25 seconds, about. And I would definitely use the word about. Sorry, that's off screen. So again, there is what, 75.75, that's 3, subtract 2.25 seconds. I would definitely use the word about. Next one, science friends find that the actual equation represents the path of is some equation down here. Let me move my paper up so you can see it. Use your calculator to determine the exact maximum height. Wouldn't that be your max? Remember, to figure out that max, you're going to have to set your left and right. So your left would be here, and your right would be there. And when you're thinking about your calculator, if you go to second trace and you want the maximum height, I believe you would push which button? Maybe the 4 for the word maximum. All right. I hope the quadratics are going well for you. If you have any questions, come by in the morning or after school and I can certainly help you. Y'all have fun. Goodbye.